Hello, this is the help video for the 4.01 quiz, which goes over proportions and unit conversions. So the standards that we're covering in this quiz are AR 3.2 and 3.3. So we're using ratios and proportions across different real-world scenarios in order to find missing values and to solve for different units of conversion over different measurement systems. So at this time, you can go ahead and open up your quiz. Like I said before, this is the 4.01 quiz on proportions and unit conversions. You can also make sure that you have your calculator open as well. You can use a calculator on all questions on this quiz. Let's go ahead and start with the first question. So the first question gives us a proportion and we have to solve for the missing variable. So the variable is, again, an unknown value. In order to solve a proportion that looks like this, we are going to utilize cross multiplication, also sometimes referred to as butterfly multiplication. And we're going to set up an equation and solve for the variable. So if we cross multiply, we have 60 times x, which we can write as 60x, equals, and we have 12 times 15. And here's especially where that calculator will come in handy. You can multiply 12 times 15, and that simplifies to 180. So now we have a one-step equation. We have 60x equals 180. Now we know from our previous studies in Unit 3 that if we're trying to solve for a variable, we want to isolate that variable by undoing anything that's around it. So we have 60x, we can divide both sides by 60 in order to isolate our variable. And this leaves us with x equals 3. So we can plug in 3 and see if this makes sense. 3 over 12 equals 15 over 60. Yes, that would make sense. If we were to multiply both of these values by 5, this would be an equivalent fraction. So again, when solving proportions, you can either find the relationship between the denominator or the numerator and then apply the same relationship, or you can use cross multiplication in order to solve. Question number 2 is a word problem, and with this word problem, we are going to set up a proportion in order to solve. So a family is taking a road trip. They traveled 240 miles in 4 hours. So I'm going to go ahead and use that as my first fraction. 240 miles in 4 hours. So my first fraction is set up. How many hours? So we're looking for hours. This is our unknown value. Hours is our unknown. Will it take for the family to travel 540 miles? So what's really important here when setting up these proportions is that we put the items that are the same in the same section of our fractions. For example, if we are given information about miles, we already put miles in the numerator here. So the next set of information that we get about miles, we should also put in the numerator of our second proportion. Then the unknown value of hours, anything that's an unknown value is a variable. So we can put that in the denominator. So x hours. And over here, we have 4 hours in the other denominator. So that's a really important step when setting up a proportion, is making sure you have comparable items or categories in the same area of your fractions. If you were to put miles in the numerator of the one fraction and hours in the numerator of the other one, it wouldn't be an equal comparison, so you would not be able to solve your proportion correctly. So again, we have 240 miles over 4 hours is equal to 540 miles over x hours. We're trying to solve for how many hours would it take for them to travel 540 miles. So again, we're going to utilize cross multiplication. I have 240x, that's a multiplication problem, equals, we have 540 times 4. And again, I'm going to use my calculator for that. 540 times 4 is 2,160. So I can go ahead and set up my proportion as a one-step equation. So now I have my one-step equation, 240x equals 2,160. Again, I'm going to use my knowledge of solving equations to divide both sides by 240, and I'm running out of a little bit of room here. And we're going to bring this up here to finish this out. So if I divide 240 by 240, that leaves me with x. And then I have 2,160 dividing that by 240. And that equals 9. So what does this mean in terms of our question? Well, if the family traveled 240 miles in 4 hours, it's safe to say that for traveling a total of 540 miles, it would take them 9 hours to make that journey. So again, when solving proportions given a word problem, it's important to put your same items in the same location of your proportion, cross multiply, and then complete your one-step equation to solve. Question 3, we have another word problem. Mark bought 15 cookies for $3.25. At this rate, how much would it cost for Mark to purchase 24 cookies? So I'm going to set up a proportion again. My first part of my proportion is going to be the information that they gave me here. I have 15 cookies, which cost $3.25. I'm going to set that equal to another proportion. Again, just like on our last slide, it's important that we put the same item in the same location. So if I have 15 cookies in the numerator here, I'm going to put my other value of cookies also in the numerator. Now I'm comparing the same item. And then the question is, how much would it cost? So we have an unknown dollar amount is what we are trying to solve for. So again, cross multiplying 15 cookies times x, and that is equal to 24 times 3.25, doing my cross multiplication. And I'm going to multiply 24 times $3.25. This simplifies down to 15x equals 78. Again, my goal is isolating the variable. I do that by dividing both sides by 15. So I have x equals 78 divided by 15 is 5.2. So it's fair to say that if it cost $3.25 for 15 cookies, then it would cost $5.20 for 24 cookies. So again, this one and the last one were very similar. Setting up our proportion, you want to put the same item in the same area, cross multiply, and then complete your one-step equation to simplify. For question 4, now we're getting into unit conversion. And the great thing about unit conversion with this lesson is you can use proportions the same way that we did previously to solve, or you can just multiply. So either way, you'll get the same answer. Build an expression that can be used to convert 6.23 pounds to ounces if 1 pound is equal to 16 ounces. So they're asking us to build an expression. What's interesting here is we are not asked for the actual solution. We just need to figure out what is the expression that we can use in order to solve. So I can set a proportion for this, and I will. 1 pound, this is what the information that they gave us. 1 pound is equal to 16 ounces. That's the conversion rate that they've provided us with. So that's my first fraction. Now, just like with everything else, I look for what other piece of information did they give me? Well, they gave me 6.23 pounds, and an unknown value of ounces because we're not sure how many ounces is in 6.32 pounds. So because just like always, I use cross multiplication to solve, let's go ahead and look at what expression we could use. When using cross multiplication here, I'm multiplying 16 times 6.23. And again, they did not ask us for the answer. They asked us for the expression we could use to solve. So to answer this question, the expression we can use to solve this conversion problem is going to be 16 times 6.23. And I found that by setting up my proportion and cross multiplying, and that provided me with the expression that I needed. Another way that you could go about solving this is simply multiplying the ounces by the pounds. Either way, you get the exact same expression, 16 by 6.23. And finally, for question 5, again, you can use that calculator to solve. I did include that as a little reminder on this question because this one's a little bit more complicated. You can also set up a proportion to solve. So they've given us 2 different conversion rates. And the great thing about unit conversion is all of this information will be provided to you on the test at the end of the year. You don't need to memorize anything that has to do with conversion in terms of what the actual conversion is. You will get a document with all of that for your test. So setting up this proportion, we have 1 mile is equal to 5,280 feet. 1 foot is equal to 0.3048 meters. We're converting 0.5 miles to meters. So we have 2 conversions that we need to do here. First, we need to convert miles to feet. Then we'll convert the feet to the meters. So let's start off first by converting the miles to the feet. If 1 mile has 5,280 feet, we can multiply 0.5 times the 5,280 to see how many feet there are in that half mile. So again, using my calculator, 0.5 times 5,280 gives us 2,640. So we know that in half a mile, there are 2,640 feet. Now I can use this foot measurement to convert to meters. So I would take what I just converted, 2,640, and I can multiply that by my meter conversion, which is 0.3048. Again, using my calculator, 2,640 times 0.3048, and that gives me an answer of 804.672. My question says to round to the nearest meter, so I would round this to 805 meters. So again, in solving this question number 5, I used both of those conversion rates that were provided. I first converted the mileage to feet by multiplying by the rate. Then I took that feet amount and I multiplied it by the meter conversion in order to find the number of meters. So in half a mile, so 0.5 miles, there are approximately 805 meters. So you can use this video again if you need to review all the questions for your 4.01 quiz. As a reminder, there's also a notes folder. And of course, we have help sessions and small groups if you have any additional questions. So I hope this video helped and have a great day.